All right, great. Good afternoon, everyone. Thank you for joining us on our digital dialogue today. My name is Justin Hugie. Today's dialogue is titled Return on Analytics, Creating Value with Less Than Perfect Data with Dr. Eric Haney, Chief Technology Officer at Lone Star Analytics. And we made sure to kind of follow the theme with the music that we had in our ads earlier. So I want to shout out Alex for the country music that we had there. So yes, thank you for joining us for our dialogue today. The meeting is being recorded, so if you can't join us for the full hour, I will be sending out a link to the recording, which will be posted onto our digital hub before the end of the day. And so without further ado, I want to invite up Eric to the digital stage. I see your camera's on there, Eric. It's been a pleasure working with you preparing for this dialogue. And so without further ado, Dr. Eric Haney.
All right. Thanks so much, Justin. So appreciate the opportunity to kind of share some of our experience and what we've been doing and working with the Air Force for several years now. And I will get the slides pulled up. And so today, kind of like Justin said, I wanted to talk about return on analytics. So really thinking about how you get a dollar back from the value and what you invest in opportunity and resources and hard dollars for analytics projects. And one of the things that we have seen is nobody has perfect data. There's always an issue. And it's always going to be tempting to put off and wait for the perfect data, for the perfect sensors, for all of the IT to be in place. But that is a long road, and it doesn't necessarily mean the decision is going to be any better. So we wanted to share a few examples of what we've seen and hopefully spur some brain waves or some thoughts or some investigation on your part. So I think I wanted to start with what are the takeaways or the things that I'm hoping to hit on. And by the way, please stop me if there's any questions or any clarifications as we talk about some of these specific programs or some of these concepts. I want this to kind of be back and forth. So if I was going to start and say anything is, the Air Force has kind of ratcheting and changing initiatives and desires. You've got higher readiness levels required. We're preparing for a peer conflict. We're kind of shifting from one mission set to another. We've got technology is ramping up very, very rapidly. We're seeing, from Ukraine conflict, what the next conflict is going to look like is drastically different. And we've kind of got that just juxtaposed with, there's uncertain budgeting. We've kind of got different changes. Space Force just recently split off. We've got changing what are the budget priorities, what are even the budget levels going to be. And then, you kind of have the other lever of, digital transformation is not new, has been going on for a long time. But in these large enterprise systems, those changeovers can take a long time to happen. And so how do we kind of bridge that gap, and how do we understand how all of those uncertainties play against each other to still make the best decisions we can with the data we have today? And so what we found is that, getting started today is, not just possible, but imperative. So getting a return on analytics, so getting your feet wet, understanding that you can build momentum and get things that are valuable and tangible today, and working towards that better future is kind of the best of both worlds. And so when you think about return on analytics, that's, what is my dollar of return for the dollar that I spent? So you've got two factors there. So on the top side, what is the numerator? So that really pushes you to focus on complex, valuable problems. If you have the best analytics in the world, but you're working on something that you only spend a dollar every year on, it doesn't matter if you have the best analytics in the world. It's not really going to move the needle. So focus on those complex, valuable problems that need to be solved. Then on the denominator side, I think this really gets to don't wait for gold-plated data. Don't wait for the perfect IT systems. Don't wait for the perfect OT systems to be hooked in and to be all network enabled. Those are fantastic things to have. Those are really helpful kind of data plumbing and data engineering problems. They make your life easier. They certainly make our life easier if they're already in place, but you can't always wait for them, or you have a problem that is too mission critical or too operationally sensitive that you have to tackle it today. And I think that the third thing that we've seen is uh, don't in the examples that we've seen of people taking a very long time to write really firm requirements and really like think about all of the I's and T's and think about everything that could absolutely go right or wrong or the scope of the problem and take, months or years to get something out the door. The goalpost shifts by the time you get something out. I think this is, kind of goes with larger procurement. And so anytime that you can set up a system and a platform so that it iterates very quickly and you can experiment, you can try things out, you can make things modular, you can democratize any of the development so that we have a mix of, contractors, subject matter experts, people in the program offices that are helping out, that really goes a long ways towards making something that is actionable, that's useful, that's sticky, and also something that you can inform all of those larger digital transformation efforts going forward, because people have the battle scars, and more people understand what is possible and what the system is capable of. So those are the kind of the highlights of what I wanted to leave you with today. And so now we'll kind of dig into in a little bit more detail about why I want you to take these parts away. So who is Lone Star? Why should you even be listening to me? So who is Lone Star Analysis? So we've been around for about 20 years. We've worked heavily with Navy, Air Force, other private defense companies. We worked in the commercial space, and really what we've focused on is being an analytics company. So we're an analytics software company. All we do is time after time go into whatever size of firm it is, whether it's public or private, small or large. They've got very complex problems that are mission critical. How do we solve them? How do we make them, help them make better decisions? And we use analytics and software to help them do that. And so we've kind of got all of these cycles of learning, of understanding what works, what doesn't work, what are the common pitfalls, what are the best tools and software capabilities to provide that types of analytics. And so, I view this as, for a lot of our customers, they've got this really big, high profile decision that, is kind of a once in a blue moon or once every, 5 years. So the people that made the last instance of that decision that came up, everybody is retired and moved on to different posts or has forgot what they did. But that's all we do. So every we're doing these projects constantly. We're doing several hundred analytics engagements a year. We've done over 1,000 over the course of the company. And so I think we're just trying to bring some of those lessons learned and some of those examples to the digital dialogue today to share, what we've seen done well and done poorly. So we are in Texas, so that's where our headquarters are. So thank you for the music teed us up. So we're here in just outside of Dallas, but we've worked in San Antonio. We're going to talk about our work with Air Education Training Command, been a long-term customer. We've also worked with the Navy Training Command down in Corpus Christi, Sinatra. So those are some of the major players that we've experienced and we've seen, and we've also seen a lot of these examples be influenced and transferable to commercial customers, whether that be oil and gas or industrial manufacturing or just in the broader aerospace community. So return on analytics. So what do we mean by that? So it's just what you get back from an investment in analytics. So if you're going to spend, $100,000 or $1 million or $10 million on an analytics project, what should you expect to get to come back to you as a better outcome, improved performance, whatever that might be? In our experience, you should be expecting a 20-to-1 at least in payback. And if you have a really big problem, which a lot of Air Force problems are very large, getting into the thousands to one of return. So if you are getting less than that, you should really be thinking about what are the levers that I can pull to improve that outcome. And so the areas to go look at to hunt to find how should I be getting a good return on analytics. So first, you could be looking at the top line. So this is kind of a bucket of decisions that we typically see. And these are typically more strategic type problems. So you're thinking about in the commercial space, how do I generate revenue? So this might be strategy decisions on what market do I go after? What type of offering should I think about? What technology should I be investing in for the future? Those types of things. In public firms like the Air Force, it might be more, I've got a budget, but now I have the options of what to invest in, which to emphasize, how to sequence things. Also, that might be a type of area that you're going to get a large return on analytics. The other way to think about it is from the bottom line. So now that I've got something that's already operational, that's already, I've already committed to doing, how do I go make that more efficient? And so that can be a couple of, you can look at it two different ways. One would be, if I have a fixed amount of resources, so if I've got a fixed budget, sorry, I'm trying to get a fixed output. So I've got, I have a production quota that I'm trying to reach. How can I reduce my cost or my resources or my overhead or my utilization in order to get that output? Or it can be something of reversed of I've got a fixed budget. That's dedicated, and I want to get absolutely as much as possible out of it. We've seen both of these come to play with our Air Force projects. Typically, more of a kind of a fixed budget. I'm trying to get more improvements. So that might be, I've got a budget for pilot training, and I'm trying to get every drop of goodness for whether that's readiness or student throughput out of the pipeline. And the ways to manage it are, certainly if you're looking at the numerator, working on important problems. So this might involve some small upfront analysis to really scope the problem or scope the universe. So within a customer base, typically we'll make sure that we are focusing on something that is large or very uncertain, mission critical. If it's not something that bubbles up, then that probably says that, well, that's not an area that you want to go focus on. Or if you are going to focus on it, make sure you do it with, kind of corresponding levels of effort. You don't want to spend a ton of money and a ton of resources polishing a rock that doesn't necessarily isn't going to move the needle and make a big difference. And then certainly the analytics cost. So that is kind of a slidable scale that you can think about of how much is it worth and how much do I need to demand from the data infrastructure in order to make this an actionable decision. So, again, this can be a sliding scale. So if I'm doing a condition-based maintenance type problem, your customers are always going to want more sensors, higher frequency sensors, more network connectivity. But do I need that to, figure out if I'm going to, change a spare tire this week or next week? Maybe, maybe not. So can I get by based off of my decision latency or my decision time frame? Can I get by with the data that I have, or inferred data, or even subject matter expert data that can fill in what sensor readings might be in a condition-based maintenance type problem? So thinking about repurposing existing data, filling in gaps with expertise are some of the things that we're going to talk about to kind of lower the analytics cost, and then also shortens the time frame to implementation, which I think is also another thing to think about, is not just kind of the hard resource cost, but time is an absolute resource. And if we're thinking about readiness impacts today, things that you can do to accelerate programs and accelerate outcomes are absolutely something that we like to think about and something we like to emphasize. So we're going to start with picking the right problem. So what we typically see that the customers kind of have in their head is, we've got a current state where typically data is disconnected. I might have some data that is, on an asset or is on a local base database. It was, collected for one specific purpose, and it's pretty challenging to repurpose it just because it's not linked. The IT systems are, old or antiquated. They don't necessarily talk to each other. And it's really just a pain to think about how to use it. And I have an understanding of what types of decisions that I would like to make. So, from a top line, it might be what new technology or services to acquire. It might be what forces to go lay out. From a bottom line, it might be condition-based maintenance. It might be resource planning. It might be identifying constraints in a logistics process, whatever that might be. And this isn't just a kind of an Air Force gut reaction. This is a human gut reaction. Is going to be to say, okay, well, I've got all of the old data infrastructure. It's it might have been useful at one time, but it's not useful for my analytics project. So I need to go think about what the ideal state is. I might have already started a digital transformation project. I might not have, but now I need to go get it all nice and neat. My data needs to be normalized. Needs to be in one data lake that is all perfectly connected and accessible throughout the enterprise. I need if I'm pulling a vibration sensor at 10 kilohertz, it needs to float through to my data lake. It needs to be perfectly available. If I've got an aircraft simulator, all of that data needs to be available. It needs to be nice and neat and user friendly. And then I can go do my analytics project. So I need to go, I might think about, the use cases up front, but really I'm going to try and get everything, customers want things nice and neat and to be easy. And I understand that. I think that's still a good goal to work towards. What we found is that can be relatively slow to get your return and can end up costing a lot more and really not driving any sort of enterprise outcomes in the meantime. So what we think is kind of a better approach is to start with, well, what problem is kind of gonna make the biggest return for the enterprise or for the Air Force, and then say, well, can we assess those and rank those and prioritize those for the things that are really important to the office and to the service today? And then because I'm going to possibly deal with imperfect data, I've got to have approaches and I need to have capabilities that can deal with a little bit of uncertainty or noisy data or messy data, or I can deal with data that's coming from multiple sources. And then if you work your way back, trying to say, okay, well, what data do I have available? Can I repurpose it? Can I be clever with how to use data from different data systems and link them together? Can I ask more questions and not just view this as a data science problem, but really as a more of kind of like an operations research problem, and ask people that understand the domain and the expertise to fill in some of the gaps for me, or to understand the relationships and the linkages. That makes a gigantic difference. That can extend out the useful life and can really kind of rehydrate data that doesn't seem to be very useful. But if you provide that contextual data, or to hook a couple of data sets together, you can all of a sudden have something that's very insightful. What we've also seen is once you start down this road, you will start to see, okay, well, now that I understand how this data is going to be used or how it could be used to provide analytics and drive outcomes, what should my transition plan, or needs to be prioritized, or what are the requirements for an ideal IT system that you work towards? Does it make sense to pull over every single piece of data if it's never going to be, if I see across analytics projects that it's typically not getting used? Well, pulling things into a shared data lake can get very expensive. You've got not just the transfer cost, but all the backups that it's going to take forever, that all of the ability to share, to have redundant systems, including everything, is not always the right choice. And I think in general, what we're trying to say is, what is good enough to make a decision? And this is a phrase that gets brought up, or a quote that gets brought up, but a good decision today is better than a perfect decision tomorrow. There's tons of problems this applies, where I've got I have to make a decision, or doing nothing is a decision in itself. Operating in a status quo environment is kind of locking in the resources that you've got. Providing an objective decision or a data-driven decision, even with messy or uncertain data, is very often better than doing nothing, or just waiting until some ideal future state. So some examples that we're going to talk about. So we have 3 examples from our Air Force engagements that we thought would kind of highlight some of these concepts. We're going to start from kind of the least mature to the most mature. So we've got 3 that are on different stages that we've worked at kind of different levels of engagement with the Air Force. So we're going to start with taking a look at pilot training data. This is a kind of an active SBIR project we're working with AFRL's Human Performance Wing. So that is kind of a relatively early stage program where we've got to have some initial results and kind of are seeing what the art of the possible is. Next, we're going to look at a condition-based maintenance program we've been working on with a joint program office, PMA 201, on an ejection seat kind of remaining useful life model to get better supply chain management and improve safety outcomes at the same time. And the last one is kind of a multi-year effort that is highly mature with the Air Education Training Command on really modeling out their entire enterprise so that they can make objective decisions for, as things change, whether that be pilot production quotas or, aircraft down or, updated transition times for new assets, whatever that might be, and then to kind of see how that they have used an enterprise model to make better decisions. All right, so the first one we've got is looking at kind of the long-term vision for transforming pilot training. So we've got, there's been several initiatives within the Air Force community and kind of the broader pilot community to get to better, more dynamic, more tailored training feedback. So you've got kind of a paradigm where as student pilots are going through the pipeline, they've kind of got a fixed syllabi. Even if they are advancing very, very rapidly, they're still held to kind of a time-based quota of what they're working on. They might get really, if they've got a really good instructor, they'll give them personalized feedback and here's what you need to work on. Here's where you're good. Here's where you're strong. Here's where you're weak. But what we found is, the instructors are very overworked. We've got, a deficit in student pilot or a deficit in instructors that is kind of exacerbated by having a deficit in operational pilots. And so the more you pull operational pilots to be instructors, the more you hurt your levels in the operational squadron. So it's a really challenging kind of push and pull. And so what we looked at was, how do I go frame what that kind of future system looks like, and then kind of identify the gaps and the research areas that we need to go look at in order to get to that vision tomorrow. So as we looked at this framework of what we needed to do to go from, I go through a training event, I generate quite a bit of data in whether that's in an aircraft, in a simulator, in a VR headset, whatever it might be. I might get some level of grading. Sometimes, very, very often happens in an aircraft. Sometimes happens in a simulator. Very rarely happens in any other device. How do I go and piece all of that data together to get real-time performance feedback that can really drive that more dynamic, tailored feedback to the student? So what we identified was that there were two main gaps that we wanted to look at. One was, if I've got these detailed data from a simulator or from an aircraft, or maybe from a new technology for a training device, how do I understand what is going on? How do I decompose that event that might be minutes long, it might be hours long, and really understand what is going on? What did the student do right? What did the student do wrong? How could I understand what happened and what could they do about it? Second area was, now that I have kind of a holistic view of what's going on with a pilot, or what's happened with the student, because this doesn't just necessarily just apply to pilots. We've worked certainly with some of the other Air Force components that does tech training and maintenance training and things like that as well. Is how do I look at these kind of performance indicators, and how do I say and understand where a student is likely to go in the future? How do I need to bend that curve to make sure I get the outcome that I want for their career and for their phase of training that they're in? So starting with kind of the first maneuver, segmentation and extraction. So you can think about, if I've got some time series data that's coming out of a system, it typically looks something like the top left. I've got, big, long time series data that comes out. I might have, tens or hundreds of fields for, and if it's an aircraft, and altitude, airspeed, yaw, pitch, roll, pilot inputs, weapon releases, all those types of things. if I've got an instructor that is, well trained and seasoned, staring at these, they can absolutely provide fantastic feedback, coach the student on what to do wrong, what to do right. Here was your flight profile. Here's what it should have been. But instructors don't necessarily have the bandwidth to do that all the time. They also don't necessarily have, if you look at a lot of the technologies that are being introduced for AR, VR, iPad training, remote facilities, I don't have an instructor staring over a student's shoulder all the time. So I've got some of this asynchronous training is happening where I don't necessarily have the bandwidth for instructors to go back after the fact and provide that feedback or tie it into what their what the students' history and experience level has been. We also have a great trove of data that has been captured over, a lot of these systems have started to capture data, at least locally, for, decades, but haven't necessarily been analyzed for trends, understanding, really to gain some insight. And so we can't ask instructors to go do some of that. So we have to have methods that kind of allow instructors to be superhuman and or, semi-automate some of the more mundane things. And so that was really the goal of what we've been working on of kind of the early stage research projects. And so what we found is, there are some methods that you can look at for time series data analysis, and you can start to look at automated detection and extraction of flight profiles. And so again, we're looking for methods that don't require a lot of data, that can deal with some noisy and some messiness. If we're talking about student training, not everybody's going to execute the same, but you still need to identify, what is a takeoff, what is a landing, what is a stern conversion, whatever the kind of common tasks that we would expect in that training event to look for. And doing it very rapidly, being able to handle lots of data. We've been able to see that we can get methods that can look at it in real time and provide the instructors the ability to do things like, hey, here was your training event today. You practiced the same maneuver 5 times. Here's kind of how you progressed over that course of the day. I can rapidly extract, here are the last 10 examples of you doing this last week or the week before. Here's it compared to the ideal version of it that I did, or that is in the training manual. Here's you versus the cohort, and all of that can be done such that the instructor can provide that real-time feedback, and we can actually get towards something that might be able to do some level of automated performance assessment, or at least being able to suggest how well a student did, so that the instructor can at least have something that's 80% correct for him to edit. And looking at predictive value of grades, so at least in the pilot world, they're really locked into a kind of a much more of a legacy IT system. So we looked at 2 years of GTIMS data. And so I think this is an instance of taking a look at what the art of the possible is with the data today is much more, it's hard to provide insight into what's going on or what the predictive value is for the current cohort, but is incredibly helpful for identifying gaps and suggestions for future IT systems. So we were able to kind of see what the predictive value would be if things like GTIMS were more integrated in with the broader career progression, whether that be demographic or initial training, kind of what the outcomes were there on hooking in what the student winded up doing in kind of longer term career progression, how that morphed back and how that fit in with any of the earlier stage training as predictive values. That gets incredibly helpful to be able to isolate people that are going to do well or do poorly, to so you can have course corrections, or you can make decisions early, as early on as possible, because it does get very, very expensive to train students. And I think we're already starting to see some of this. Some of these outcomes are already being taken to heart. So I know that there's a experiment happening right now within AFRL, where I think one of the things that we saw really highlighted with the existing IT system is TIMS really only provides granularity for satisfactory or unsatisfactory grades. That gets very challenging to get predictive insight if you're just giving a binary yes or no on student outcomes. And so they're already doing some experiments with, I think a 7 or 10 point grading scale that really forces the instructor to get a little more objective and get a little more fine grained about it, about how a student is doing, and that provides a lot more predictive value, or at least has the potential to. So I think these are the types of iterations and the types of experimentations and experimentation loops that I think are really, really helpful as you're putting out requirements and scoping for next generation enterprise systems.
Eric, this is Justin. Just a quick question based on the graph. The scale on the right side, does that represent the success of the outcome?
No, we were looking at what skills correlated with which other skills. So we were looking at which skills in the Introductory to Fighter Fundamentals course were predictive of overall success. And kind of what we found was there was a handful of skills that tended to be leading indicators or were representative of the kind of the broader student outcome. So, I think if you talk with instructor pilots, pretty self-explanatory things like decision making or what was it? Situational awareness, like things where is the student processing all of the information that is coming at them very rapidly from multiple places? Are they able to synthesize all of that data into kind of a coherent thing in the time allotted? And so I think that was one of the things that we could find from the data available was what skills tended to be the highlights and which ones to go focus on and really key in on for current cohorts.
Got it. Thank you.
Mm-hmm. So the second project, so this is one that is a little more mature. This is a couple of years that we've been working on. So this is with PMA 201. So they're a joint program office that procures cartridge actuated devices and propellant actuated devices for joint services. Specifically, we were looking at the ejection seat for the T-45 and the F-18. This is so Navy aircraft, but a lot of the concepts are applicable to other ejection seat and other propellant devices. And so they were really struggling or had a kind of a recurring issue. So they have an ejection seat that is relatively old in its design. It has several parts of the ejection seat that have a stabilizer that it can be so the stabilizer keeps the propellant acting as expected, but it degrades over time and it gets accelerated with exposure to temperature. And so they had, as installed by the manufacturer, they had come up with a kind of a scheduled calendar-based remove and replace program. There was no way to test the remaining useful life without destructive testing. And so they kind of got in a mode of just replacing it on a scheduled basis. The issue was there were several incidents over the years where the device was acting unintended, whether that be they tried to eject and it didn't eject, or it just exploded when it wasn't supposed to. It was just sitting on a tarmac, and it kind of, as the picture on the bottom right showed, blew a hole in the canopy as it was sitting on the tarmac. So that is obviously a safety critical issue. And so their kind of approach there was to just move that calendar-based remove and replace closer and closer and closer, where it started at 10 years. And when we started the program was down to 2 years. And so that is kind of has a massive impact. So if you just look at, gut math, that says, well, now I've got to go procure 5 times more of those devices. The explosive kind of industrial base is kind of one of those that is very small, is very susceptible to very lumpy procurement, don't have a lot of players that are available. And so asking more from those vendors can get pretty challenging and can cause a lot of knock-on effects. And certainly causes safety of flight issues as well. So it was really a something that was head hurting the program office when we first got involved. And one of the things that they were struggling with was, because I have a more of a legacy fleet, I didn't have any, there were no sensors on the explosive devices, and also very few sensors within the cockpit of the F-18, because all of the sensors are installed for, operational use or for controls, very little for managing the health of the ejection seat of these specific propellant devices. And so, again, going back to gold-plated data, their initial gut reaction was, we know it's susceptible to temperature. We've got to put sensors in our aircraft. That's the first thing we've got to do in order to get a condition-based maintenance program, or understand when something is safety critical and needs to be removed ahead of its expected life. That's the first step that we've got to go to. But years-long estimate. So how much risk are we willing to live with for, the 3-5 years it takes to get something flight qualified and within the cockpits? Well, what we found was it was possible to do a sensorless digital twin. And so what that means was, we're not going to wait on installing a sensor, but it would certainly be nice. And so what we did was we worked with the engineering team at PMA 201. We worked a lot understanding and looking at and kind of peeling back the chemistry of the specific propellant devices. And what we found was, chemical engineers and chemists designed that system to operate as intended. So there's a deep level of domain understanding of how that chemistry works. But that's not necessarily understood or transparent to the maintenance facility or to the people at PMA 201 that are operating and are kind of planning out procurement and maintenance plans of these systems. So putting some of that, getting some of that knowledge understood and transparently laid out, understanding how temperature is likely to impact, for instance, the activation energy of the specific chemicals at play, looking at what level of stabilizers should be expected from a manufacturing standpoint. So that was one of the things that we did know from kind of a process and a workflow standpoint. They did love some level of lot testing whenever they took control, and they would provide kind of a minimum threshold of stabilizer level, but there was some uncertainty in how much stabilizer was there upon acceptance and installation. But then the other part of it was, well, exactly how hot did these devices get? So this is the data and the insight that the Navy was initially looking at, or was wanting to have a sensor help out on this front. Was there a way to fill in this gap with some very focused data collection? So kind of what we looked at was, what are the installation locations? So where are these systems operated? Where within the cockpit are the devices located? And so what we did is we kind of came up with a data collection plan. We worked with some of the test pilot squadrons, and did a kind of a focused data collection, so that at least we could get a rough estimate of the relationship between ambient temperature and cockpit temperature based off of different, sun levels and time of day and time of month and whatever that might be, so that we could at least have a directionally correct understanding of what the cockpit temperature was going to be. And so what that wound up with was a kind of a digital twin of the chemistry of the explosive device that didn't rely on sensors, but would accept them if available, and is certainly improved and calibrated to a tighter degree if I do have direct sensors. It didn't require any labeled failures of, here's what a premature explosion looks like. Here's the data in the time history of what a device that didn't go off, what that looks like, because we are building in all of the domain expertise and the kind of explicit relationships between the chemistry. It didn't require any of that, but it was helpful for calibration. It didn't require any sort of connected IT system. It was available to have kind of disparate connection from bespoke IT systems. And so what that wound up with was, you kind of have, this is an example of a result from an actual device. So what you see is when I installed the device, here's the stabilizer level. And what you'll see is it goes down quite a bit when it's exposed to high temperatures. So these are typically summer deployments, or when it's deployed somewhere in the desert. The Navy likes China Lake, or places in California that get to 105, 110 pretty frequently. And then you'll see winter exposure where you don't have very high temperatures. You still have some level of degradation, but not that much. And then year two is where it was removed and replaced. And so what you should see is that was what the device, how much stabilizer was left in the device was 1.6 percent of the propellant weight. And what we expected for the range was 1.6 to 1.7. So this band of uncertainty, with the dark line being at 1.62 rounding. So it's calibrated, it's understanding relatively well what the stabilizer levels were, and then everything past that was kind of a future projection of where it would have gone in the future if it had stayed installed. And so, what does this mean for the decision that the program office is trying to make? So, if you look at it from that project in a nutshell, this kind of shows you from installation based off of different deployment locations what that remaining useful life would have been. So they have a kind of a blanket level of, once it hits less than 1%, oh, sorry, 0.2% is where they have set as a useful, or that's where they're expecting a replacement to be. So whenever they remove a propellant and throw it away, they're expecting the safety of flight to only be impacted if it's 0.2% or less. But what you see is that doesn't happen very often. So if you have location A, which is one of their hotter environments, at year two, I'm already unsafe. I was unsafe, over here in the 10th or 11th month. So even the 2-year remove and replace schedule is probably not sufficient for safety of flight. But for most other locations, in the summer months, I'm certainly degrading, but I have well over 2 years before I am crossing that threshold. And I have some temperate locations where I am hardly impacting the stabilizer life at all. I'm still significantly safe for flight after 5 years. And so this allows them to understand what the impact of deployments and different operating locations is on useful life, and allows them to make a more informed engineering decision. So this is already getting used to as squadrons are going out for deployments or for operational tours of duty. They're using this to kind of inform what they're doing and extension of life requests. And the last one is certainly the most mature. So looking at enterprise modeling of the Air Education Training Command. So the things that we currently have in scope and the things that we have looked at from an analytics perspective are undergraduate pilot training. So primary training for regardless of which airframe you're going to go into, and then starting to work on the formal training units for things like F-35 and V-22 and C-17. And so you can kind of see all of the places that we have fielded so far. And really what it's kind of a multi-use tool. And so what we found is there's kind of a series of ongoing decisions that have to be made by AETC and the training squadrons of, how do I meet my numbers? How do I get back on track? If I have a shift in resource availability, whether that be instructors or a runway goes down for maintenance, or I have a new radar installation, or I've got a change in syllabi, or I have I get a new bank of simulators. How does that impact my ability to perform and meet mission? These guys are under pretty constant expectations of improving student outcomes. So allowing them to rapidly understand what those decisions are going to be and how they make the best of a uncertain future it was kind of the driving force behind a lot of the analytics we provided. And so as we've worked on this, when the future becomes the past and we're able to look at student outcomes, we're able to get within 98% of the actual answer. So, only 2% error, very often closer than that. And some of the tangible impacts that we've looked at are doing kind of an asset analysis, understanding what the future looked like for T7 acquisition and on-ramp. we were able to suggest and have AETC understand what the implication of premature divestitures of T-38s were going to be, and pulled 52 that were very likely to be struck into active duty so that they could continue operations. And as we've seen, the T7 has shifted to the right. That was very helpful to keep them on their production levels. And so very often when we have things like hailstorms or COVID or things that are going to have significant dips in student production, if as we've used our analytics, we've very often improved outcomes by up to 30% in student throughput in those very adverse, challenging situations. And so how do we do that? So we looked at what is the customer, in this point, what do I wish I knew about tomorrow? Whether that be, flight hours, how many flight hours can I train a student? What do I have the capacity to do? How much is it going to cost? How many students can I get through? What are my limiting factors? So what can I do about it? So these are the things that I wish I knew about tomorrow. So these, as we worked with different stakeholders in the AETC community, these are the things that they cared about. These are the things that I know. What do I know today? It might be how many aircraft are available, where are they based, how many students are in each operation, what is the syllabi requirements. Well, those are in 8 different databases. And they're not all in databases, by the way. A lot of them are in, Excel spreadsheets and Access database files, are, sitting in PDFs for syllabi requirements. Well, that takes a lot of effort to extract that data, but that doesn't mean it's the wrong answer, because you can provide a lot of insight. And I think in an ideal world, and something that I think the Air Force is actively working towards, is getting a lot of those, whether that be REMIS or IMDS or GTIMS, all of those collected in a common data lake and a common data infrastructure. There's still a lot that you can do today. And so, now you can get to, once you kind of put all those puzzle pieces together, you can come up with something that can speak to multiple personas, whether that be at the headquarter level. So we've got people all the way from, General Robinson at AETC can log in and understand, here's how all of the squadrons are doing. Or I can get down to a very specific persona that is, I only care about, Vance Air Force Base. What is going on with, with my community? How do I need to operate at a more tactical level? You can kind of see what's going on. You can do all of these what if analyses as things change, and inevitably you have road bumps. And so you really, the kind of the goal is to get to, what is my limiting constraint, so that I can understand what to do about it. What levers do I have available, whether that be, asking instructors to work an extra shift, shifting aircraft from one base to another, updating my student intake requirements, whatever that might be, so that I can meet my expectations, or at least be able to understand what the future is going to look like if I keep my decision the same. And so what we found is one thing that is incredibly helpful to tackle these types of problems is very modular software platforms, and also things that are as no code as possible. One of the reasons we found this is incredibly helpful is, as we're working on mission critical systems, having a degree of transparency is incredibly helpful for explainability and trust, for verification and validation. It's also incredibly helpful so that you can democratize and get as many people from the domain and from the operational side to use the tools, and to start to put their thumbprint on the solutions. And so we've had, Air Force operators, Navy operators, maintenance personnel, acquisition and program offices that have been able to look at our solutions and understand what's going on, be able to again put their expertise down and be able to move that. So, we built a series of built-in capabilities that allow us to do things in a no-code environment. We think that's been incredibly helpful. So I think regardless of whether it's us or something commercial or something internally built by the Air Force, being able to democratize and have something no-code has also been very helpful for the people that get to use it. It also makes it very, very much faster to iterate on it, because it's not going back from a full coding perspective. You're starting from a higher floor of capability every time you tackle an analytics project.
Eric, we do have a question here. Do you have any use cases for modeling a future workforce based on competencies?
Yeah, so we've done that in a few levels. So one from a maintenance perspective. So we've looked at both O-level maintenance and D-level maintenance from a kind of a skill mix perspective. So looking at the uncertain input or demand signal that is coming through and what types of skill levels will be required. And kind of so that lets you understand, hiring, firing, attrition, retirements, how all those factors play out. So that's kind of one level that's more kind of just doing the accounting of what certifications or skill types are required. We've also, swung to the other level and done really kind of in-depth proficiency-based modeling. So this gets really important if you're doing things like, very skilled maintainers or pilots, how different training media, different training exposure will impact those readiness curves, because a lot of those really complex motor skills are challenging to learn and will attrit very, very rapidly if you don't practice them. So we have looked at a lot of these approaches for doing that type of modeling and that understanding of how a human will absorb and retain and attrit understanding and skill levels. Perfect. And so I think that kind of wraps up a lot of the things that I wanted to talk about. So things to leave you with: don't wait on the perfect data. What you've got is very often acceptable, at least to get something directional. Start now. Even if you don't get good analytics out of it, at least you will understand what gaps you need to fill and what you need to prioritize for the future, for that future state. The other thing I'd say is, do your homework up front. A little bit of questioning today can make sure that you're working on the right problem and working on it to the right level of fidelity and detail. Experiment fast, iterate. Don't write the 100-page requirements document for an analytics project. Get started now. Get some feedback. Figure out what works and what doesn't work, and as much as possible, go for no code. So you're not, data scientists are very expensive. Even for I know it's hard to train those skills for the Air Force and for the civilian side, but it's also very expensive from a industry perspective. So democratize it, get it in the hands of as many people as possible, get it people that understand the domain in the Air Force and the mission. That really helps. And I think I saw a question. I'd be happy to take that.
Yeah, I just wanted to see if this would be a fit. So I was working with a group at AFMC who was very concerned with the modeling the engineering competencies that we needed and how many people we needed AFMC wide going forward into the future in different areas, different engineering kinds of competencies. So that's a lot different than, say, the pilot training community, right? Where we're trying to pump out a certain number of pilots. So getting to that type of competency, have you done anything like that?
I think that's most similar to the things that we've done with kind of the depot level maintenance, where you're
okay.
It's not just a this person is a mechanic and they can only do they can only do these things. It gets more into, this type of mechanic has these types of skills, and these types of actions require these types of skills. So it's not just this task can only be done by this person. You kind of have more of it could be done really well by a seasoned person. It could also be done by management if required. So starting to think about what are the types of tasks that are going to be required of the engineering community. What specific types of engineers can do that? Is it something that, a broad understanding of engineering can tackle that problem, where I need somebody that has 20 years of electrical engineering experience to do this problem, and if I can't do that task with that type of person, it's just not getting done. So understanding kind of what that more fine-grained demand signal looks like, I think is a challenging problem, but it's something that is doable, and it's not something that it's not just the engineering community that has to deal with that. A lot of people are really thinking about workforce management at a long-term perspective And you do need to look at that from that level to be able to plan, or you just for an enterprise as large as the Air Force, it's just not possible to move on a dime.
And do you need to usually start with a very well-established competency model in order to make much progress on that problem?
I would say it's not required to have the detailed competency model, but it certainly helps a lot to, whether that be from an HR perspective on understanding like, certifications or job titles or things like that. We have also worked quite a bit with, research psychologists and industrial psychologists to really get in the nitty gritty of, knowledges and skills and abilities. So that is a pretty familiar pairing for Lone Star to kind of work with that type of person, whether that be, the NOC TSDs, or the AFRLs, or the Aptimas of the world, if you're looking from the commercial side. That I think that type of mindset pairs really well with our modeling and our approaches, and they can be very complementary of each other. Because then you're not only getting the kind of the long-term strategic forecasting of what those variables and those outcomes are going to be, but you're also getting as much tied into the human side of it as possible to understand, what does it mean to be, good at a specific skill, or understand what to do, or what do I have, am I really comprehending what a human is capable of.
Thank you.
Mm-hmm.
Awesome. So are there any other questions for Eric?
I just wanted to say thank you, Eric. It's been a great dialogue. I want to personally apologize for our audience today, and not the people who are here. I appreciate everyone joining us, but something had to have happened with our communications as we sent it out. We have never had an audience this small, so we're not sure what happened. We have chosen to go ahead and record the dialogue, and we will distribute it out to the entire invited audience as well, just sending them all a link to it. So we're not sure what broke down for us. Typically, we send out as a meeting invite, and people who are interested in these things add it or don't. Obviously something went wrong, and we're going to probably spend the next couple of hours troubleshooting that. But we are appreciative of your time. We have captured the recording. We will be publishing it on our internal digital hub. And after we've sent out a link to that to the larger community, if we have questions come in and there's enough interest in trying to reach out and engage with you personally, then we might want to go ahead and schedule another one of these if you have the time and interest in doing that. But we can't thank you enough for being here today, and we do apologize. Our average participation list tends to be between 250 and 350, and so something has to have gone wrong here, and we still haven't. We'll figure that out in the coming hours.
No problem. I understand things happen, but I really appreciate the opportunity. And yeah, once I see the link, I'd be happy to send that out as well. So I really appreciate it. And thanks for the chance, and I'd be happy to come back again.
Awesome. Thanks for everyone that joined us. Really appreciate it. Thank you, Eric, once again. And again, like I echo everything Cheryl said. Sorry for what happened. We're gonna find out what happened, and make sure it doesn't happen in the future.
All right. Well, thanks, guys. Y'all have a good rest of the week.
All right. You too. Thanks. Bye.
Bye.